is applications of integrals. So we're gonna find, actually 7.1 is almost all review. We've done this stuff before. In fact, the questions in the warm-up or in the notes, you would be able to do them. But we'll talk our way through them. 7.2 is finding areas in the plane rather than just finding areas under the curve. Maybe finding an area between two curves. It's pretty straightforward. So if you have one above it, one below, how do you find the area in between them? 7.3 is a huge section. It has a ton of stuff in it. It's volumes. There's like 6 different types of like problems in that section, 7.3. So it would be, well, go ahead.
Is that going to be its own section test, or is that going to be with 7.1 and 2?
You'll have a quiz 7.1, 7.2. You'll have a quiz 7.3, 7.4, and a
When's that
test.
quiz? Like what day of the week next week?
Thursday, because we don't meet Tuesday
If we go to
and
Hockey
Wednesday.
State,
We're
gonna
here, but there's no juniors or seniors, so we'll be telling us.
Yeah.
Like Amanda when everyone goes to Nelson?
Yeah.
So I'll talk more about 7.3, but we'll take like areas and revolve them around axes. So if you had a circle and revolve around an axis, you'd have a donut sort of thing. You'd have to find the volume of it. You could find its surface area. We could find arc lengths. We have lots of stuff in 7.4 or 7.3. 7.4 is not as heavy as 7.3. But 7.1 today, if we look at our notes, it says coasting to a stop. You got velocity versus time. It says how far have we traveled. So if we have a series of measurements of velocity, we have some data for velocity. To find how far you actually travel, we have several different techniques to find its distance. So what's one way we could find how far we travel given the velocity data?
Intensity. Wait. No, like you find the derivative, so you have the s, right?
How do you find s? Yep, you're given velocity.
Yeah.
What'd you say?
So yes, and then you just find the antiderivative. And then
Okay, so if we had an equation, we could find the distance by finding the antiderivative velocity equation, right? So that's one. So, but we don't have an equation here, so could we find an equation?
Yeah. You would do a regression.
Excellent. So we could do a regression, have an equation, find the antiderivative, like basically integrate with an equation, but you might have to do a regression. So in the example coasting to a stop, that seems to be a pretty straightforward what type of an equation?
Exponential.
Yeah, exponential decay. So that would actually have a decent regression equation. Just to jump ahead briefly to the second example, the regression is not always going to be straightforward. I don't even know what we would use for that regression. But in this case, the regression would work pretty well. So that's one. If you want to write them down, you can find the integral using an equation. Sometimes you'd have to do a regression. What's another way we could find the area